Hello, it's Mr. John here, and welcome to our lesson. Today we're looking at this book, 100 Facts, Solar System. It's a great book, and we'll be looking at how the solar system was formed, how the sun was formed, and how this all relates to us, our planet, here on Earth. You'll learn some new words, I hope, some interesting vocabulary around how the planets were made and how the universe is formed. Let's get into the book. I hope you enjoy. Let's start.
Let's look at the cover of the book which our lesson is based on today. The title of the book is called 100 Facts, Solar System, and it's by Miles Kelly Publishing. Let's turn to the page and let's start the lesson. What is the solar system? 1. The solar system consists of the sun and everything that orbits, moves around it. 8 planets orbit the sun, and more than 160 smaller moons orbit the planets. There are also millions of other objects circling the sun, including asteroids and comets. The pull of the sun's gravity holds the solar system together. Okay, so let's turn to the next page and let's look at the different planets of our solar system. Our solar system has 8 planets orbiting around the sun. Let's name the 8 planets, starting with the planet closest to the sun. Okay, so let's have a look at the picture and you'll see the planets, bottom left, going up to the right. Let's start with the first one, Mercury. Then Venus. The next one's very special, isn't it? Earth. Followed by Mars, Jupiter, Saturn, Uranus, Neptune, and lastly, Pluto. Now, Pluto has been classified as a subplanet, but we'll still include it. Okay, so there's the planets, all 8 of the planets, including the subplanet Pluto. Let's turn to the next page and learn a little more. Now, here's a good question. Where did it all come from? Let's keep reading. Number 2. The solar system began as a vast, swirling cloud of gas and dust called a nebula. Most of it was made of hydrogen, the lightest and most common element in the universe. So according to science, everything was mainly made out of hydrogen. That's interesting, isn't it? Let's keep reading. Let's turn the page. Number 3. Around 4.6 billion years ago, the solar system began to form. It may have been started by the huge explosion of a star, a supernova. Shock waves from the giant explosion would have compressed, squashed the nebula. Gravity then took over, pulling the nebula inwards and causing it to collapse in on itself. Okay, let's have a look at the picture there down the bottom right-hand corner. We can see an exploding supernova. That sounds incredible, doesn't it? A star that exploded. Let's keep reading. Let's turn the page. Now let's look at point number 4. As the nebula collapsed inwards, it started spinning. Clumps of gas and dust formed in the collapsing cloud and grew bigger as gravity pulled more and more gas and dust towards them. A dense mass formed at the center of the nebula, which increased in temperature and eventually became our sun. The remaining gas and dust flattened into a spinning disk, later forming the planets. So if we take a look at the picture, the photograph on the bottom right-hand corner, we can see an image of what the nebula may have looked like after it exploded and started spinning, starting to form the sun and the planets. Let's keep reading. Let's turn the page. Right, let's read number 5. There are still signs of the spinning motion of the shrinking nebula today. The sun, planets, and moons all spin, and the planets travel around the sun. Wow, let's keep reading. Let's look at this small point on the left-hand corner. It took about 100 million years for the planets to form from the nebula. Wow, 100 million years. That's a long time, isn't it? Let's turn the page now and let's look at a few more extra facts. Number 1, dust particles and tiny bits of rock in the spinning disk clumped together. 2, as these clumps grew bigger, their gravity pulled more dust and rock towards them. 3, the balls of rock and gas grew bigger and bigger, eventually forming the planets. So there's some extra quick facts. Sorry about the quality of the images there, but the next ones should be much clearer. Let's keep moving. Let's turn the page. Now let's look at the major part of our solar system, and it's where the word solar system gets its name from. Solar means the sun. Let's look at this slide. What does it say? A star on our doorstep, the sun. Let's learn a little bit more about this most important part of our solar system, the sun. Let's turn the page and read some more. Okay, point number 6. The sun is the star at the center of our solar system. It looks so much bigger than the other stars in the sky because it's much closer to us. It's about 150 million kilometers from the Earth. So yes, the sun is actually a star, but it's very close to Earth compared to all the other stars that we see in the sky. Let's keep reading. Let's turn the page. 7. The sun looks small in the sky, but it's a giant compared to Earth. It's so huge that 109 Earths would fit side by side across its middle. Wow, the sun is so big. 109 Earths would fit side by side across the middle of the sun. Let's look at the next slide. Here we can see a comparison. So we can see the big orange ball representing the sun. Now if we look right down the bottom towards the right, we can see the word Earth with a long arrow. That's how small the Earth looks compared to the sun. It's just a little tiny dot, isn't it? So as we can see, the sun is much bigger than the Earth. Let's keep reading. Let's look at the next page. Point number 8. The sun is made of super hot gases, mostly hydrogen and helium. Its core, center, is the hottest part. The temperature here is as high as 15 million degrees centigrade. Wow, that's very hot. Let's look at the next point, number 9. Scientists worked out how the sun shines in the 1920s. The extremely high pressure in the sun's core causes particles of hydrogen to smash into each other and fuse, stick together, to form a new substance, helium. This is called nuclear fusion. Every time it happens, energy is given out. So in many ways, the sun is like a massive nuclear reactor, creating huge amounts of energy and heat to heat the planet Earth. Let's keep reading. Let's turn the page. Number 10. About 4 million tons of the sun's mass vanishes every second. This happens because nuclear fusion changes some of the sun's mass into energy. The sun has been losing this huge amount of mass every second for about 4.6 billion years. Isn't that interesting? So every second, some of the sun is shrinking and being used up. Let's look at number 11. Energy produced by nuclear fusion travels from the sun's core to its surface. This takes up to 200,000 years. When it leaves the sun, it takes just over 8 minutes to reach the Earth. Isn't that interesting? So it takes about 200,000 years from the energy from the middle of the sun to reach the surface of the sun. Yet it only takes 8 minutes for that energy, for that light, to reach Earth and provide our planet Earth with all the sunshine and the heat that it needs. Let's finish up and let's look at the next page. Light and warmth from the sun sustains all of the life on the earth, including us. So that's the end of today's lesson. Isn't that incredible how the sun is formed and the universe is formed? And without the sun, Earth wouldn't have any life at all. No plant life, no animal life, no human life. We can all be grateful for our universe and for our sun.
Well, that's the end of today's lesson. Wasn't that interesting, learning more about our solar system and the sun and its relationship with the Earth? Finding out more about how the solar system was formed and how the sun was formed as well, and how important the sun is to us all here on Earth and all of the life here on Earth as well. I hope you started to pick up a few new words as well. Well, that's it for today. Goodbye.